Finally, we're going to look at integrals that require the substitution x equals a times secant of theta. So if the integral has the square root of x squared minus a squared in there, this is a good substitution to try. We're assuming here that the angle is either between 0 and pi over 2 or pi and 3 pi over 2. This is the domain of the restricted secant function. This means that we're making the substitution theta equals secant inverse x over a. Dx d theta is a times secant theta tangent of theta, so dx gets replaced by a times secant theta tangent theta d theta, and of course the square root of x squared minus a squared equals the square root of a squared secant theta minus a squared. Pulling out the a, we get that this is a times the square root of secant squared theta minus 1, which is a times the absolute value of tangent of theta, but because we've chosen the angles in the appropriate intervals, the absolute value of tangent of theta is just tangent of theta here. Let's evaluate this integral 1 over x squared times the square root of x squared minus 25. So our appropriate substitution is x equals 5 times secant of theta. And now we must replace dx and x and the square root of x squared minus 25 by their equivalents under this substitution. Dx d theta is 5 times secant theta tangent of theta, so dx is 5 times secant theta tangent theta d theta. And as mentioned above, the square root of x squared minus 25 is going to be the square root of 25 secant squared theta minus 25. Pulling out the 25, we get that this is 5 times the square root of tangent squared theta, which is 5 times tangent of theta. And now replacing everything in the integral by its expression in theta, we get our integral is equal to dx, which is 5 times secant theta tangent theta d theta, divided by x squared, which is 25 secant squared of theta, times the square root of x squared minus 25, which is 5 times tangent of theta. And we can cancel that 5 times tangent of theta and one of the secants, and we're looking at the integral of 1 over 25 times 1 over secant of theta. But of course secant of theta is 1 over cosine theta, so we're looking at the integral of 1 over 25 times cosine of theta d theta. Now it's pretty easy to integrate cosine of theta, that's just sine of theta, so our answer is 1 over 25 sine theta plus c, but we're not quite done yet. We were given the integral in terms of x, so we have to convert back to x's. So theta is secant inverse x over 5, and our answer is 1 over 25 sine of secant inverse x over 5 plus c. Now we're going to use our triangles to see if we can get a simpler expression in x for our answer. So we want to create a triangle with an angle theta, where secant of that angle is x over 5. So theta here is secant inverse x over 5, and secant of the angle, which is the hypotenuse over the adjacent, should be x over 5. Well, the simplest one to construct is something with a hypotenuse of x and an adjacent of length 5. And of course then the third side is predetermined. Using Pythagoras' theorem, it's the square root of the hypotenuse squared minus 25, which is the square root of x squared minus 25. Now I would like to evaluate sine of secant inverse of x over 5, which is sine of theta in this triangle, and that is the opposite over the hypotenuse. So that's the square root of x squared minus 25 over x. And now I can substitute this into my answer and I get my original integral is 1 over 25 times the square root of x squared minus 25 over x plus a constant. You could also use this substitution to get the following well-known integral, which a lot of people add to their list of integrals to remember or refer to. The integral of 1 over x times the square root of x squared minus a squared is 1 over a secant inverse x over a plus c.